close friend, Wayne Yokoyama. Wayne is the 11th professor at Washington University School of Medicine. He was the head of rheumatology there for many years. And besides being a rheumatologist, physician, scientist, he's very, very dedicated to the education of physician scientists and now runs the double combined MD PhD program at Washington U, which is a very active and very large program, probably the largest in the United States. As you know, Wayne, from your notes that you have in your program, Wayne received his MD at the University of Hawaii and then trained at the University of Iowa in rheumatology. And in research he did there also, and at the same time, after that he went to the NIH. And there he started his, after his started his independent career, he focused his research on the issue that we call in basic immunology innate immunity, the capacity of the immune system to make a first line of defense. Wayne has become one of the leaders, if not one of the best laboratory in the world, studying a very special class of cells, which is in our blood in small amounts, and which are called natural killer cells, by the acronym NK. Natural is because they are normally circulating in all our tissues and exercise the first line of defense. Killer because actually when they touch a cell that is virally infected or a cancer cell, they actually kill the cell and impart a death program on the cell. And that's why we call them NK. Wayne has has made major contribution to the analysis of these very important cells that give us a first line of defense. And in my opinion, he's done 3 major pieces of work, which I'll summarize very, very briefly in 2 or 3 sentences. First of all, he actually was able to identify the gene segment that encodes the protein that distinguishes these cells. This was a big arbeit, a big piece of work, to actually take all that gene segment and identify a new series of molecules that actually opened then investigations in what they were doing in the cells and identify a number of pathways of action of these cells. Secondly, and very importantly, using genetic information as well as molecular tools, he was able to establish convincingly that these cells actually had a first line of defense against a number of viruses. And without these cells, viral infections became extremely severe. This was a beautiful piece of work that established what were the molecules involved in the action of these NK cells. And lastly, and what was one of the most distinguished pieces of work, he was able to establish when 2 cells come together, one cell does something to the other. The natural killer or NK cell kills the other cell. To do this, there has to be 2 proteins interacting. Cells don't just come and leave. They have to glue with each other. And to do that, you have to have a lock and key interaction. So he was able to identify what was the key and what was the lock in the target cell that was virally infected or in the cancer cells, and what was the actual key of the natural killer cell. But what was most astonishing, and particularly in the context of the disease that you're studying, when this happens on virally infected cells, you don't want the NK cells to be actually killing your own cells. You want to stop that. So he then identified a series of other molecules that were called inhibitory receptors. And those molecules, the key and lock, did not translate in the death of the cell. The key and lock translated actually in a stop signal. You cannot kill your own cell. This was a it was a paradigm shift in how we understood cell-to-cell communication and cell-to-cell interaction. So for all these pieces of work, Wayne has actually been rewarded by the immunology community. He received the Arthritis Prize, which is the biggest prize that we immunology give every 3 years by the Immunology Congress. He's a Howard Hughes Medical Institute investigator. He's an awardee of the National Academy of Science. He's a member of the National Academy of Science. And now we're going to give him, from your foundation, the Howley Prize. Please welcome Wayne Yokoyama.
Emil. I think you know my work better than I do. Well, Chairman Parrish, incoming Chairman Shuey, President Klippel, board members, distinguished volunteers, everybody's interested in arthritis here, are my fellow award winners, ladies and gentlemen. I think I have included everybody. It is really with great honor and humility that I'm here to accept the B.C. Howley Senior Arthritis Prize. And I especially want to thank the Arthritis Foundation and the Howley family for establishing this very prestigious prize in arthritis research. When I learned I was about to receive the award, I had a chance to scan the list of previous Howley Prize award winners, and I was truly amazed to find myself among the giants in arthritis research who have advanced our knowledge of arthritis to the point where we are much closer to a cure than when Bracington and I were rheumatology fellows in training. At that time, all we had for rheumatoid arthritis was intramuscular gold shots. And in retrospect, it's not clear that the gold shots actually worked. But that's the best we had at that time, and you know, in retrospect, it really wasn't all that long ago. Now, to be sure, we don't have a cure yet, and there are many forms of arthritis that need better treatments. But I would like to think that basic immunologists like Emil and myself, and the other Howley Prize winners, and many of my colleagues in the immunology community, have contributed fundamental scientific knowledge that have led to very effective treatments for these diseases like rheumatoid arthritis. Rheumatologists can now administer drugs that are like magic bullets that can specifically block the immune system, and this results in dramatic improvement in most RA patients. And we now have many related drugs in our armamentarium that are very effective. And the future continues to look bright for arthritis patients because we have many new and exciting findings in the laboratory which are being turned into drugs by pharmaceutical companies and biotech companies like Amgen. But I would like to use myself as an example of how difficult it is to do true cutting-edge research in arthritis. The late Ira Goldstein, the first president of the American College of Rheumatology, recruited me to my first faculty position in the rheumatology division at the University of California in San Francisco about 20 years ago. Amazingly, he allowed me to work on NK cells that Emil summarized. And I say amazingly because these cells were first described and discovered because, as Emil discussed, they kill cancer cells. That's the reason why they were first discovered. So what do NK cells have to do with arthritis? At the time, the consensus was probably nothing. And in fact, even among immunologists, most could have cared less about NK cells. Yet Ira and my bosses let me work on these cells because I thought we had a valuable clue to understanding how they work and how they participate in the immune response. And as Emil mentioned, we ultimately made significant strides in learning how to specifically identify these cells and learning how they work at the molecular level, enabling us and now many other laboratories across the world to appreciate the critical role that NK cells play in immune defense. So when we fast forward to today and apply this knowledge to arthritis, it is amazing. And I really want to emphasize the word amazing again, because it now appears that abnormal NK cells cause certain forms of juvenile rheumatoid arthritis. So let me say that again. A cell discovered because it can kill cancer cells turns out to be extremely important in juvenile rheumatoid arthritis. This connection would not have been possible without years of research devoted to understanding the fundamental basic ways in which NK cells, and indeed this applies to the rest of research for understanding how the rest of the immune system works. It's difficult work because this type of scientific investigation is different than the way most people think about science. Science is not simply learning a bunch of already known arcane facts and applying them to solve a problem. It turns out to be much more challenging than that. Science is about discovery, about learning one of nature's secrets that she never revealed previously and doesn't want to reveal. Sometimes these secrets are uncovered when you least expect them. Sometimes you do an experiment and find an unexpected result that causes you to ask, what experiment did you really do? And forces you to go back to the drawing board. With such a moving target, it's actually amazing that we can make any progress at all. But finding these discoveries is what motivates us as scientists to make these discoveries, because it is so satisfying to make a discovery which can advance our understanding of diseases like arthritis and help find the cure. But it's also why it takes many years of dedicated work to make progress. And for arthritis, that's why we need the help of all of you in the audience to continue to support the endeavor to find the cure for arthritis. It'll take lots of volunteers, lots of scientists, lots of effort, lots of donations to keep us moving forward to this goal. And I'm pleased that I've been able to contribute to this effort in my own little way, and I thank all of you in the audience and the Arthritis Foundation for helping us in the laboratory. I especially want to thank the committee for selecting me for this award. John Harden is sitting at my table and was chair of that committee. But it really should go to, this award should really go to the many dedicated researchers in my own laboratory who were the ones who really did the work. I want to thank again Emil and John Atkinson, who couldn't be here today, for nominating me and for their mentorship and friendship. They were the ones who recruited me to WashU many years ago and allowed us to continue our work on NK cells. I want to thank my many mentors over the years, starting with my high school biology teacher, who's still alive, Miles Moroka, and who got me started in biology research. Don't forget your high school teachers. And my medical research mentors, Drs. Mitsui Okuyama, Parker Staples, Bob Ashman, Ethan Shevak, David Cohen, and Ira Goldstein. And finally, I want to acknowledge and thank my partner in life, Lynn, and our kids, Christine and Bree, for putting up with my love of research that sometimes conflicts with my love for them. Thank you again. Thank you.
Congratulations, Dr. Yokoyama, and on behalf of the entire Arthritis Foundation and the people that we serve, allow me to say thank you. It's a really inspiring story of your life research.